This is Josh White with JW Math Tutoring. In today's video, I'm going to go over the unique problems from linear paper practice test number 11. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I begin going through these 10 problems from linear paper practice test number 11, I just want to mention a couple things. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there will be a link to a PDF file which has the 10 problems from this new linear paper practice test number 10. Basically, these are the unique questions that are on this linear paper practice test 11 but do not appear in Blue Book. So basically the rest of the questions, the other questions, are ones that basically appear in Blue Book. So I'll have a link to both the questions just specifically from this practice test and also to one combined file that has all of the unique questions from linear paper practice tests 4 through 11 available in both the description of the video and in the pinned comment as well. So you can download all the unique questions, or if you've already done 4 through 10 and just want these 10 questions to do, you can go ahead and download that as well. All right. So with all that being said, let's go ahead and get started here. First question. So first we're looking at module 1. There's basically 4 questions from that one, and then there'll be 6 from the second module. Here you have basically an isosceles triangle because I tell you PQ is equal to QR. So that just means that the angles across from them must also be congruent. Therefore, the correct answer to this is just letter D. The value of x must be 24. Now, even if you didn't know that, you could still just go through and do 180 minus 132 minus 24 and get 24 that way, as well. Just the fact that all 3 angles in a triangle have to add up to 180. Okay. Next up, question number 9. This is just basically a relatively straightforward evaluate the function question. You plug in 81 for x, and then, take the square root of its 9, and then add that to 300. You get 309. Correct answer for this one is just letter C. Of course, you could do this work in Desmos as well. You could type the function in and then just, do g of 81. It just gives you 309 as your answer. All right, the next one, number 22. Okay, so this problem is basically, it's dealing with the concept of weighted average, but you can actually also solve this by technically setting it up as a frequency table in Desmos. If you want to take the weighted average approach, essentially what you're doing is you're taking the number of gray seals, multiplying them by their mean length, which is the 88. Then adding to that the number of, Muskeget Island, they're both gray seals. Muskeget Island gray, seals, the number of them times their mean length. Then Sable Island, number of them times the mean length. You add all that together, and then you divide by the total number of seals, which is basically 240 plus 120, or 360. Just go to Desmos. You can just type this whole thing in. It should work out to 90. So let's just double check that. 40 times 88 plus 120 times 94. On the bottom, it's going to be 360. Yep, and notice we get 90. Okay, so that's one approach to this. Correct answer is letter B. An alternate way you could do this, I don't think it really saves that much time because there's only 2 different values here, is you can enter it as a frequency table. So basically, the value which is the mean length, will go in column A, and then the frequency, the total number, will go in the second column, the Y column. And then what you type in is total x1 times y1, that basically says to multiply across each thing and then sum them up, which is essentially what I wrote out when I did the weighted average calculation, and then divide by the total of y1, which is again the 360, and notice you get the 90. Okay, if you want to find out more information about how to find the mean value when data is presented in a frequency table, then check out my ultimate Desmos guide to digital SAT math. I will post the thumbnail on the screen showing the specific video in which I go over basically that operation. Okay, next up, I'm going to have to zoom out to get all the answer choices on here. Number 23 from Module 1. Here you have a graph of a function that has been shifted up 4 units. What is the equation of the function itself? So, a couple different ways to do this. First, okay, so here's one. So I guess here's one approach. Notice this thing goes through the point 0.08, right? That means the original function will go through the point 0.04. So take 0, plug it in for x, and then 3 to the 0, take the opposite of that, blah, 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 and then see which one of these gives you 4 as your output. That's basically going to be your answer. So if you go to Desmos and do that, let's get rid of this. -3 to the x plus 1. Okay. So what we want is f of 0. Okay, so notice for the first answer choice, I get 0, 0. That is not correct. Second answer choice, notice I get 0, 4. That's what I'm looking for, and that's correct. And this is the correct answer right here. Okay, so that's one way you could do this. Another way you could do this is you could go to Desmos and you could put in some points. So for example, we have the point 0.08, and we also have the point 2.0. And then we could do a linear regression. Sorry, not linear regression. It's going to be regression, but it's exponential, not linear. -3 to the x1, and then plus b. So for this function on the screen, okay, yep, it goes through these 2 points. This graphed function is -3 to the x plus 9. Now, this is the f of x shifted up 4. So just subtract 4 from your b value. 9 minus 4 is 5. Therefore, the actual function itself is going to be -3x plus 5. So that's just an alternate way you could get the answer as well. All right, let's move to Module 2. Number 3, very, very basic, easy question. Just finding the area of a rectangle by multiplying its length times its width, which is 56 times 28. That's going to come out to 1568. It's letter D. Obviously, you'd probably just use a calculator to do that unless you happen to have it memorized. But that's it. You know other work to be done. This next question is one that I actually had missed when I originally compiled the unique questions from this Linear Test 11. So it's not in the original recording, but after I found out that I missed it, obviously I went back, did this problem, and it added it to the recording that you're seeing now. So this is question number 10. And basically, you're given the graph of a linear inequality here, and it wants to know which is the solution to it, basically which thing matches this here. So notice this is a horizontal line. Therefore, it's going to be, the line itself, is y equals some number, right? Looks like it's y equals 36. So right off the bat, these two are gone. So you're down to these two here. So the question is it less than or equal to 36 or greater than or equal to 36? Well, notice the shading is above the line, i.e. the shading is where the numbers are greater than or more than 36. So therefore, correct answer is just going to be this, letter D. Now, of course, you could also just go to Desmos. And you could just plot the answer choices in Desmos, and just see which one matches the graph that you're given on the screen. So, for example, the first one is x less than or equal to 36. Okay, that one clearly doesn't match because it's got the vertical line. And then the next one, you just switch the direction of it. Okay, so those are obviously wrong, and then you could check answer choice C. All right, that looks a little bit closer, except notice the shading's on the bottom, not the top. And there we have answer choice D. This matches the correct graph that you're given in the problem. All right, so that's how you could solve this problem. And now we'll continue with the rest of the problems from this linear paper test 11. Next up, number 14. Here, again, this is a very straightforward question. This is the equation of circles in standard form, which of course we know is equal to r squared. Therefore, what's the radius? Well, if r squared is 169, the radius will just be the square root of that, which will be 13. So the correct answer you'd type in here is just 13, and that's it. Okay, 21. This is a question. This is another percentage question. I guess you'd probably consider this an advanced percentage question. And so what I would do is I would go to Desmos. So the first equation, okay, the number A, and then what that's equal to is 55% less than B. So what you have to realize is here you're technically starting with B and then you're taking away 55% of it. So you're starting with B and you're subtracting 55% of it. Then we're told that B is equal to 320% greater than 160. So that means we're taking 320% of 160, and the greater than means adding it to it. So you need 320% of 160 plus 160. So when we type all this in, what's the value of A? It's 302.4. That's it. Don't need to do any work. Desmos will do the calculation for you. And that is your exact answer. Don't think they're technically, yeah. See, here's the thing. There is an equivalent fraction, and they actually list this in the answer guide for it, but this is 6 total characters. You couldn't type this in. You know, if you tried to type this in, you wouldn't be able to type everything in, so you can't. I don't know why they list that, but 302.4 is what you would have to submit in Blue Book. All right, next up, question number 22. So, which of these displays the maximum value of the function as a constant or coefficient? Okay, again, this problem, it is so much faster and easier to just go to Desmos, find what, the maximum value of the function is, and then look at the answer choices, see which one has that in it. Okay, so right here at our vertex, our maximum value is going to be 24 because maximum value is always the y value. So which of these has a 24 as a constant or coefficient? All right, it's obviously letter C. It's right here, the 24 that's being added. Essentially, C is written in vertex form, so that's just going to be the correct answer. All right, let's look next now at number 26. I'm going to go through 2 different methods you can use to solve this problem. And you can decide which one you find easier. So here's our right triangle. X is 90 degrees. W is somewhere over here. X, WX, or XW, whatever you want to call it, is perpendicular to YZ, the hypotenuse. All right, we know WY is 572. We know WX is 429. Okay, here's method 1, and this involves similar triangles. Okay, you have the overall triangle here, Y, X, Z. Then you also have this triangle right here. Okay, if I take that and I reorient it so that it's like the corresponding parts match up with the large one, so like W has to be down here because W is the right angle, right? And then Y has to be at the top because y is the same angle measure in both, and that means x has to be down here in the corner. Okay? So these two triangles are similar because when you have a right triangle and you draw an altitude to the hypotenuse of the right triangle, it basically makes three similar triangles. The small, and the big, they're all similar to each other. So because of that, notice here, x and z are the same angle measure. So in other words, the tangent of x is equal to the tangent of z. The tangent of z, which is what we're trying to find then, is going to be equivalent to, and sorry, I forgot to label these things in my picture. This is 572, xw is 429. So the tangent of z is equal to the tangent of x. The tangent of x is equal to the opposite, 572, over adjacent, 429. So that just reduces down to one of these fractions, and of course we'll go to Desmos just to figure that out. It's going to be 4/3, 1 1/3, letter D, correct answer, right here. Okay, so that's the similar triangle approach. Here is an actual numerical kind of basic trig approach. So this is like method 1. So this is method 2. Let me know if you find this approach faster, simpler, easier. Okay, so first thing I would do is, looking at this triangle up here, I would find the measure of angle y. Because I would say, well, the tangent of angle y is equal to opposite over adjacent. So in other words, 429 over 572. Okay? Y is going to be equal to, and for this obviously I'm going to go to Desmos. Trying to resize the window here. There we go. Okay, I'll call it capital Y inverse tangent of 429 over 572. Of course, I need to make sure I'm in degree mode. Right here, click the wrench, change to degrees. Okay, so that's the measure of angle y. It's like 36.87 degrees, approximately. That means z is going to be 90 minus that 36.87 degrees. Okay, so now I'll just go here to Desmos and I'll just do 90 minus y. Because I defined it as y, it carries over the exact value, and I'll say, okay, that's equal to capital Z. So z is 53.13 degrees. So now, what's the tangent of angle z? Tan z. Right there's my answer, 1.33, repeating, or 4/3. So that's an alternate approach, just using basic trig that you could use as well. So decide which one you find easier. All right, next up, last question here, number 27, module 2. This is basically a unit conversion problem. We have 46, I think, how did I abbreviate this? I think I did NM squared, nautical square miles. We're converting it to square kilometers and kilometers, and they give us the conversion factor here. 1 nautical mile is 1.852 kilometers. But because this is an area, basically two-dimensional, you have to take this scale factor, this conversion factor, and you have to square it, or if you want to write it out twice, you could do that as well. But the point is, you don't just multiply by it once. You have to multiply by it twice, i.e. you have to square it. So then you can just go into Desmos. Just basically 46 times 1.852 times 1.852. And it says here, of course, to the nearest tenth. So this would be 157.8. Or, I don't know why you would do this, but if you convert it to a fraction, you can technically also enter in 789 over 5. I mean, I don't think anyone would consider doing that, but it is an acceptable, it's an answer that would be accepted. All right, so I hope you enjoyed the solutions to these linear test 11, or linear paper test 11 unique problems, i.e. the 10 problems that do not appear on the Blue Book linear paper test number 11. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. If you have any questions or comments or alternate solution methods, feel free to leave them below. Otherwise, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It's now over 7 hours of tips and tricks and up to 73 practice problems to help you ace the digital SAT math section.